Okay, today we're going to go through some practice problems for chapter 2.2. Remember that this is the basic assumptions, axioms about the real numbers. Okay, so the first problem that we're going to look at, the instructions are to name the axiom that justifies each lettered step. Okay, so what we have is quantity v plus 9 plus quantity w plus 8. And to go from this step here, or this, this expression here, down to this first expression, all we did was reassociate our numbers, right? So, you could think about this as v plus 9 is kind of like a plus b, and then w plus 8 is kind of like c, right? C is w plus 8, a is going to be v, b is going to be 9, and we know that quantity a plus b plus c is the same as a plus quantity b plus c, right? And that would give us, v plus b was 9 and c was our quantity w plus 8. So the justification for this first step is going to be the associative axiom, and I'm just going to abbreviate that as AX, of addition. Okay? Now, to go to this next step here, well, when we compare term by term, we have, this term didn't change. This didn't change. This W, well, that did change, right? It got moved over here, and this 8 got moved over here. And we know that when we're flipping the order in a sum, that's just the commutative axiom, and I'm going to abbreviate addition as ADD. Okay. Now, to go to this next step, well, this V didn't change. What did change is that instead of grouping 8 plus W, we've now grouped 9 plus 8. And we know that when we talk about changing the grouping, then we're talking about the associative axiom. Okay? To go to this next step, the only change that was made is we substituted 17 for 9 plus 8. And we know that we can do that because of the substitution principle, which I think was discussed in one of the early sections of chapter 1. Okay, now when we go down to this next step, the thing which changed is the order of the terms in this sum here, right? Instead of 17 plus W, we've got W plus 17. So when we talk about changing the order, then we're talking about the commutative axiom of addition. Okay, finally, to get to this last step, all we've done here is just change the grouping, right? Instead of grouping W and 17, we've grouped V and W. And we know that when we talk about changing the grouping, it's the associative axiom in this case of addition, okay? And if we had a step at the end that said something like v plus 9 plus w plus 8 equals v plus w plus 17, then we would have been applying many times over the transitive property of equality, right? Because, you know, this would be like A equals B here, and then, you know, B equals C, C equals D, D equals E, E equals F, F equals G, and finally A is equal to G by the transitive property. Okay, so that's it for that example. We're going to do another example. We are going to do, well, we're not going to do it all the way. I just want to briefly talk about number 11 here. So, I want to make one suggestion for this, which is to try to keep track of things that can be canceled, right? For example, I've got a 9 in the numerator here and a 9 in the denominator here. So I know that when I multiply 9/2 with 2/9, and in fact I've got the 2 in the denominator and the 2 in the numerator, you know, these are just going to cancel each other out, right? 9/2 times 2/9 is going to give me 1. So I just want to point out to be on the lookout for those kind of things so that you're not just multiplying all the way across, like 9 times 3 times 2 times 49 divided by 2 times 7 times 9. Try to make your life a little easier and simplify a little bit as you multiply. Okay. I'll just write that here so that you keep it in mind. Simplify while you multiply. Okay. The next example that we're going to do we're going to take a look at number 21 here. So 21 is asking us to solve for C. Okay, so what we have is C plus 12 plus 23. Okay, this is, you know, the same as C plus 12 plus 23, right? That comes from the associative axiom. And that's actually the same as this statement right here. So if I were to subtract from both sides 12 plus 23, like I don't even need to bother adding them together. I can just subtract that quantity from both sides. I'm going to wind up with C equal to C. Okay? So my solution is going to be the set of all real numbers. Okay. We're going to do number 30 here. So number 30 is talking about a star operation that's defined over the set of natural numbers. And the first thing that we need to do is find 3 star 4 for, you know, this operation here, where A star B is A times 2B. So what that means is we're just going to plug in A equals 3 and B equals 4. That's going to give me 3 star 4 equals, and I'm going to plug it in over here. That's going to be 3 times 2 times 4, which is just going to be 24. Okay, I'm going to box that answer. And then tell whether the statement is true or false. For all A and B in the set of natural numbers, A star B is a natural number. So, is there any combination of two natural numbers that we could plug in to A star B equals A times 2B where we don't wind up with a natural number? And I'm gonna say no. So the set of natural numbers is the same as the set of positive integers. And anytime that you're multiplying two positive integers, you are going to end up with another positive integer. So this statement is true. Is star a commutative operation? So that's asking, is A star B the same as B star A? Well, that's the same if A times 2B is the same as B times 2A. And we already know that multiplication is commutative. And, you can kind of ignore that factor of 2 in some sense, right? Because we could just factor it out to the front each time, and we get 2AB equals to 2BA, right? That's coming from, if we were being really careful here, we would write this as A times 2B is the same as A times 2 times B. That's coming from associative, which is the same as 2 times A times B. That's coming from commutative, which is the same as 2 times A times B. That's coming from associative. So that's giving us this expression right here. We could do the same thing here, and we'd wind up with this guy, 2 times B times A. And those are going to be the same. So yes, this is a commutative operation. Is it an associative operation? So this is asking if I have A star B star C, is that the same as A star B star C? And let's take a look at that. So A star B, we know we're kind of running out of room a little bit. So let me make myself a little bit of room. Let me make myself a little bit more room. Messing up my arrows slightly, but I think we're okay with that. Oh, you know what? I had all that room down there. I had so much room. That's okay. Now we have so much more room. All right. So Now we're just gonna substitute in the operator, the star operator. So for A star B, that's gonna be A times 2B, like this, star C. And we're wondering if that's gonna be the same as A star, now it's B star C, so that's gonna be B times 2C. Okay, now we need to do one more, well, it's really two more star substitutions. Whoops. So this A times 2B star C is going to be, I'm going to substitute this in for A and this in for B. So that's going to give me A times 2B times 2C. And I'm asking, is that the same as A, right? This is what's going to go in for A, and this is what's going to go in for B. A times 2 B 2C. All right. So if we do some rearranging, so we'll start with this expression here on the left, and we're going to try to see if we can make it look like this expression here on the right. Okay, so the expression here on the left is going to be the same as A times 2B 2C, right? I'm just moving these parentheses. I'm going to group the 2B and the 2C instead of the A and the 2B. Okay, now I'm going to group, instead of 2 and B, and then leaving 2C, I'm going to group B and 2C. So this is going to be 2B 2C. And this is exactly my expression up here, which I was able to get to using the associative properties, or the associative axiom of multiplication. So this is also going to be a yes, that the star operator is associative. All right. We're going to do another example. So here it's asking us to tell whether each relationship is reflexive, symmetric, and or transitive. Okay, so remember that reflexive is A equals A. Symmetric is, if A equals B, then B equals A. Transitive is if A equals B and B equals C, then A equals C. Okay, so now we're asking about whether, I'm going to do 37 here, we're asking about whether greater than is reflexive, symmetric, or transitive. So this will be reflexive. It would be reflexive if A is greater than A. And A is not greater than A because it's exactly equal to A. So this is not reflexive. Let's take a look at symmetric. So if A is greater than B, then B is greater than A. And that's definitely not true. So it's also not symmetric. All right, finally for transitive, we're saying we're asking if A is greater than B and B is greater than C, then A is greater than C, question mark. So A is greater than B, B is greater than C. Well, B was bigger than C and A is bigger than B, so yes, this has to be true, that A is bigger than C. So yes, transitive. And then, you know, if I were boxing my answer, it'd be kind of this whole thing here. All right, that's it for today.